Hello data scientist, welcome to Skillgate. In this tutorial, we shall build a powerful fake news detection model using the pre-trained BERT with the help of transfer learning. By the way, this is part number 3 to our 3-part transfer learning series where we have earlier discussed the intuition behind transfer learning and the refresher on what BERT is and how it works. So do refer to these earlier parts to reinforce your understanding. I'll share the link to these videos in the description part below. Now let's get started on building a fake news detection model in this third tutorial. For introductions, we are Skillgate and we are on a mission to bring you application-based machine learning education. We launch new machine learning projects every week, so make sure to subscribe to our channel and hit that bell icon so you get notified of all our new ML projects. Well, this is a snapshot of the dataset we are using. I have also provided a link to this in the description part of this video for your ready reference. Here we have these two CSV files, true.csv and fake.csv. Both of these files have the same exact data form. We have the title of the news in this column 1, then the article text followed by the subject, which is basically the category of the news article, followed by the date on which this article was published. For our use case, we shall merge both of these files into a single large dataset and add an additional column called label that will have true mentioned against all the observations from this true.csv and fake mentioned against all the observations from this fake.csv. Moving on, this is our step-by-step plan on building this project. First up, we load our dataset, that is the true.csv and fake.csv files. Then we merge them into one and generate true fake labels. Post that, we obtain the pre-trained BERT model to use it as the base of our fake news detection model. As we know by now that BERT has insane language comprehension capability, so it shall make our fake news detection model better understand news context and hence make intelligent predictions on news being fake or not fake. In the next step, we define our base model and the overall architecture. We shall be using PyTorch for defining, training and evaluating our neural network models. After that, we freeze the weights of the starting layers from BERT. If we don't do this, we lose all of the previous training. This is something we discuss in the second part of this series. Then we create our trainable layers. Generally, feature extraction layers are the only knowledge we reuse from the base model. To predict the model's specialized task, we must add additional layers on top of it. On this step, we will also define a new output layer, as the final output layer of the pre-trained model will almost certainly differ from the output we want for our model, which is a binary fake and not fake. As last step, we fine-tune our model. I'll talk more about fine-tuning in the next slide. And once we are done, we move on to make predictions using our fake news detection model on unseen data. BERT is a big neural network architecture with a huge number of parameters that can range from 100 million to over 300 million. And training a BERT model from scratch on a small dataset would always result in overfitting. So it's better to use a pre-trained BERT model that was trained on a huge dataset as a starting point. Then we can further train the model on our relatively smaller dataset, and this process is basically what is known as fine-tuning. To do this, these are the 3 approaches that we generally adopt. First one is to train the entire architecture of our neural network. Second one is to train some of the layers while freezing others. And the third one is to freeze the entire architecture, where we basically freeze all the layers of the pre-trained BERT model and attach a few neural network layers of our own and train this new model. Note that the weights of only the attached layers will be updated during model training as part of this third approach. And in this tutorial, we will use this third approach where we will freeze all the layers of the BERT during fine-tuning and append a dense layer and a softmax layer to the architecture. We'll talk more on this when we go into the coding stage. Now let's get started with our fake news detection model building using Python. This is our project folder on Google Drive, having all the project related files in a single place. I'll share a link to this Drive folder in the description part below. Here this B2 fake news detection is our Jupyter notebook. Let's fire it up to get started. In my case, I have it open already, so let me switch tabs. By the way, to proceed with this tutorial, a Jupyter notebook environment with a GPU is recommended. The same can be accessed through Google Collaboratory, which provides a cloud-based Jupyter notebook environment with a free GPU. For this tutorial, I shall be working on Google Colab, and I highly recommend you to do the same. So once we are here on Google Colab, to activate the GPU runtime, I click on runtime, change runtime type, and I select GPU. It's already selected in my case. And then I connect to the runtime. Alright, now let's go section by section through this code file to do a quick code walkthrough. Over here, first up, let's set up the environment. Here in this first code cell, we are installing Hugging Faces Transformers library. This library lets us import a wide range of transformer-based pre-trained models. Additionally, we are also installing PyCaret. Let's do it. Alright, we are done. As next step, we import these essential libraries. And then we mount Google Drive to access our project folder using these steps. And lastly, I set my working directory to the project folder within Google Drive. If you're working in your local machine, you may use this line of code. Alright, in the next section, we are loading the dataset. Here first up, we load true and fake CSV files as pandas data frame. Then we create this column called target, where we put the labels as true and fake against the respective line items. And lastly, we merge the two data frames into a single data frame called data by random mixing. So let's see how the data looks now. So this is how our merged dataset is like. It has 5 columns: title, text, subject, data, and the new target, which has these binary labels, fake and true. Now this target column has string values which a computer wouldn't understand. So we need to transform them into a numeric form. To do this, we use pandas getDummies method to create a new column called label, where we put all fake labels as 1 and true labels as 0. To visualize the changes, we may use this head function once again. So now we have this additional label column with the numeric labels created. Next up, to check if our data is balanced across the two labels, we may plot a pie chart. So as you may see, our data is fairly well balanced. Alright, in the next section, we split our data set into training, test, and validation in 70-15-15 ratio. Now we come to the BERT fine-tuning stage, where we shall perform transfer learning. Here first up, we load the BERT base model that has 110 million parameters. There is an even bigger BERT model called BERT large that has 345 million parameters. For our use case, however, BERT base would do just fine. So let's load it. Along with it, we are also importing the BERT tokenizer. Then as next step, we prepare our input data. To train our model, we shall use the title of the news article. For sure, we could also use the entire news article text, but handling that much data would require more compute resources than what Colab has on offer and will take a long time. So we limit our scope here to just the title of the news article, and trust me, even with this, we shall get a strong accuracy score of something around 90%. Now, before we go to the preparation stage, we need to figure out how we standardize the word length of our news titles, as it would vary from one article to another. For this, we plot a word count histogram to understand what the typical word length is across different titles using this code script. Here we may see that majority of the titles have word length under 15, loosely speaking. So we shall perform padding on all our news titles to limit their word length to 15 words in the tokenization stage, which is this next code cell. Now, before we get into the tokenization, let me quickly show you how the BERT tokenizer works. For this, I have this dummy list called sample data here, which has these two sample sentences, basically the elements of the list. Then I tokenize this sample data by calling the BERT tokenizer on it, and I'm marking padding to be true. Let's see what we get. As you may see, the output is a dictionary of these input IDs, token type IDs, and attention masks. Here, input ID contains the integer sequences of the input sentences. These integer 101 and 102 are special tokens added to both the sentences at their beginning and end, and 0 represents the padding tokens. So we have two zeros here because this second element is 2 words short of the first. Then attention mask contains all zeros and ones. It tells the model to pay attention to the tokens corresponding to the mask value of 1 and ignore the rest. Token type IDs identify which sentence a token belongs to when there is more than one sentences available. For your further reading, I have added this reference link here in this code cell. With this understanding, now let's go ahead to tokenize our sequences, that is titles in our training, test, and validation sets. Alright, now our train, test, and validation sets are tokenized using the BERT tokenizer. As next step, we convert the integer sequences to tensors. And as last step here, we create these data loaders for both the train and validation set. These data loaders will pass batches of train data and validation data as input to the model during the training phase. Let's do it. Next up, we freeze pre-trained model weights. If you recall, earlier I mentioned that in this tutorial, I would freeze all the layers of the model before fine-tuning it. So let's do it now. Freezing the layers will prevent updating of model weights during fine-tuning. If you wish to fine-tune even the pre-trained weights of the BERT model, then you may not execute this code. Moving on, as next step, we define our model architecture. We are using PyTorch for defining, training, and evaluating our neural network models. Over here, post our BERT model, which is this. We are adding these couple of dense layers, 1 and 2, followed by the softmax activation function. Then we define our hyperparameters. We are using AdamW as our optimizer. It is an improved version of the regular Adam optimizer. Then we define our loss function, and finally we keep number of epochs as 2. Even with collapse free GPU, each epoch might take up to 20 minutes to finish, so I'm keeping this number as a low value to not keep waiting on forever. So as a quick recap, we have defined the model architecture. We have specified our optimizer. We have declared our loss function, and previously we have also defined our data loaders over here, right? Now, as next step, we have to define functions to train, or rather fine-tune and evaluate our fake news detection model. This is the train function that we have written. And this next one is the evaluate function, which uses the validation set data. Let me run this. And finally, we can start fine-tuning our BERT model to learn fake news detection. As a training may take around half an hour or so, in the interest of time, I will be leaving this part to you. For this demonstration, I already have this C1 fake news weights kept in this drive that I trained a while back before recording this video. Let me call these weights to our runtime now to continue further with our code review. Let's do it. Now let's build a classification report on the test set using our fake news detection model. As you may see, we are getting a strong 88% accuracy. Both precision and recall for class 1 are quite high, which means that the model predicts this class pretty well. If you look at the recall for class 1, it is a healthy 0.84, which means that the model was able to correctly classify 84% of the fake news as fake. Precision stands at 0.92, which means that 92% of the fake news classification by the model are actually fake news. As last step, let me also run predictions on these sample news titles. First two here are the fake ones, and the next two are the real ones. Now let's see what our model predicts. So quite rightly, our model classifies all 4 of these reviews correctly as fake and not fake. Guys, congratulations to you for making it to this point. Do give yourself a pat on the back for completing this transfer learning fake news detection project all by yourself. To summarize, in this tutorial, we fine-tuned a pre-trained BERT model to perform text classification on a small dataset. I urge you to fine-tune BERT on a different dataset and see how it performs there. For example, you may do a sentiment classification or a spam detection model. You can even perform multi-class or multi-label classification with the help of BERT. In addition to that, you can even train the entire BERT architecture as well if you have a bigger dataset. In case you have any doubts or you got stuck somewhere, leave a comment below and I'll help you out. You may write to me over email, WhatsApp, or schedule a free one-on-one by visiting my website skillkit.com. I post new machine learning projects every week, so do subscribe to my channel. Happy learning to you. Bye.